Hi, my name's Caleb Smith. I'm from Team 24, who was working on making BattleBot subsystems. My specific subsystem was creating a driveline controlled by a joystick. I also had my hand in making our presentation, and I assisted several of my teammates in writing their code.
My name's Grant Wellington, and I worked on subsystem 2 of the turret, which involves controlling it and firing. I worked on also the code for it and the integration of a joystick two-stepper.
Hello, my name is Seth Kreitz, and I worked on the Claw subsystem. I also worked on the code, and I worked on the integration of the buttons and potentiometer to the servos.
Hello, I'm Alexander Harves, and I am from Team 24. I worked on the RFID locking mechanism and the buzzer system. I also worked on the P3 initial aim, as well as the video. For Project 3, we decided to create a BattleBot. Our 4 subsystems were a claw mechanism, a launch mechanism, a locking mechanism and buzzer, and a drive mechanism.
So this is Caleb Smith's subsystem, which is the driveline. It's powered by a 9 volt and a 12 volt battery. The 12 volt is from IEP1. The stepper drivers, which are the main drivetrain, are powered by 2 stepper drivers, which were gotten in IEP1 also. The stepper drivers are powered by a joystick, which was from our kits. And as you can see here, if the joystick moves right, they'll move in, or left, I apologize, they'll move in 2 directions, and then if it's moved the other way, they'll move in the opposite direction. This is forward with different speeds. This is backwards with different speeds. And the system also has a switch that can switch from high power mode to low power mode, which allows the motors to run at 50% if you were trying to go slower or conserve power. Also, on the topic of conserving power, the battery has a switch on it so that you can turn off the servos.
The subsystem consists of 2 elements. The joystick, which controls the servo to aim up and down, which connects to the servo, and the servo is connected to the motion sensor, which has an on and off switch right here. When turned on, it detects motion, in which when motion fires, the projectile will fire. It's aimed up. If it gets within closer to the projectile, it fires. And to control the speed of the motor changing, I have a PMW to control how fast and slow it moves. Turning it all the way down prevents any motion up and down. Turning it halfway allows for a slow up and down turn. And full motors has a motor of 500 RPM. The video.
This is the Claw subsystem, and in this system, there's a potentiometer, and there are two buttons, and they both control one of the servos. So the potentiometer controls the servo, and as you turn it, the servo turns, and this servo turns a full 180 degrees with the potentiometer. And this servo would be a vertical mount that the claw would be mounted to. So the servo would act as a guidance for the claw. So whenever you move it up and down, you can actually articulate and get it closer to the ground or higher up in the air as needed. So this would be mounted to the side of the vehicle like this, with the claw mounted to this surface. The second potentiometer is one of the claw arms. The other arm would be a fixed arm, and this claw is controlled by the buttons. So in this position, it would be open, and in this position, it would be closed. And as you can see, just one press of the button closes it. It won't do anything. You can click the button as many times as you'd like, and it won't do anything. And then another button, a press of the other button, will open it, and they're color-coded. And yeah, that's all for my subsystem.
This is Alexander Harms's subsystem. It is an RFID lock and buzzer subsystem. The subsystem is powered by a 9-volt battery and uses an RFID lock to turn on an LED, as well as allow a button to turn a buzzer on and off. The subsystem incorporates 2 RFID keys. One is the white RFID card that unlocks the subsystem, while the other is a blue RFID tag that locks the RFID system. As a demonstration, if I were to place the white card in front of the RFID scanner, the LED turns on and allows for the buzzer to be turned on and off. Subsequently, when the RFID tag is placed in front of the subsystem, in front of the RFID scanner, the LED is turned off, and access to the buzzer is no longer available, as it can no longer be turned on or off. Overall, we had a lot of fun with this project. If given more time, we would have likely done more with the project and taken it further than we already have. And we would have also likely connected it up a lot more. Overall, we learned a lot about Arduino.